Over the last few years, the recent onslaught of severe weather that has swept across various states has not only unleashed significant quantities of rain, but also potentially triggered a surge in the proliferation of oversized pests referred to as floodwater mosquitoes. These formidable storms, characterized by their ferocity and destructiveness, have not only left a mark through their precipitation, but also possibly contributed to the rapid reproduction and spread of these particular mosquito species. Frequent in Oklahoma, floodwater mosquitoes, also known as gallinippers, have the remarkable ability to reach sizes up to 6 times greater than regular mosquitoes. Justin Talley, a livestock entomologist at Oklahoma State University Cooperative Extension, highlighted that although the disease risk associated with this specific type of mosquito is minimal, it poses a significant nuisance. In the realm of entomology, floodwater mosquitoes are often linked to causing extremely painful bites when they come into contact with humans. The size of these mosquitoes is noteworthy, making them more noticeable to individuals, particularly when the temperatures rise, as pointed out by Talley. The primary concern does not revolve around the transmission of diseases by these mosquitoes. Rather, it is the abundance of breeding grounds that facilitate their proliferation, with stagnant water serving as the ideal habitat for their reproduction. This intricate relationship between floodwater mosquitoes and their breeding sites underscores the importance of monitoring and managing standing water. Oklahoma experiences significant populations of floodwater mosquitoes during the months of May and June, particularly following periods of intense rainfall. To effectively minimize the presence of mosquitoes in the vicinity, it is crucial to eliminate any accumulated standing water around the premises. This preventive measure is fundamental in thwarting the breeding and proliferation of mosquitoes. When it comes to preventing water accumulation, it is crucial to inspect various locations where water could gather, including bird baths, garden containers, and even tree crevices. It is essential to ensure proper drainage of any standing water in these areas to reduce the risk of mosquito breeding grounds. In case stagnant water is unable to flow away from the premises, there are certain solutions accessible for addressing the issue. These solutions come in the form of products known as insect growth regulators, which can typically be administered in granular form using a conventional lawn fertilizer spreader. In essence, these regulators are designed to inhibit the growth and reproduction of insects, thereby helping to control population levels effectively. Standing water poses a significant risk as it can act as a prime location for mosquito breeding, as stated by Talley. Floodwater mosquitoes typically thrive in stagnant or minimally flowing water bodies found in wooded areas or alongside roads. The absence of movement in water bodies such as roadside ditches facilitates the ideal conditions for these mosquitoes to breed. Talley emphasized that in cases where water is stagnant, the risk of mosquito development is significantly higher compared to situations where there is a continuous flow of water, as moving water impedes the mating process for mosquitoes effectively. To minimize the risk of being bitten by a floodwater mosquito, there are several precautionary measures that can be taken. These steps are essential to reduce the likelihood of experiencing an unpleasant mosquito bite. In general, pests tend to exhibit increased activity during the evening hours and in areas with ample shade. Their propensity to bite extends not only to humans, but also to livestock and household pets. Engaging in outdoor pursuits calls for a prudent approach towards attire. It is advisable to opt for long-sleeved tops and full-length pants, particularly when indulging in outdoor activities. While it is true that floodwater mosquitoes possess the ability to penetrate clothing with their larger size, donning appropriate attire can serve as an initial protective barrier against their bite. Many people questioned whether these mosquitoes were genetically modified. Genetically modified organisms have been a subject of intense debate and scrutiny due to their potential impacts on the environment and human health. One area of concern is the unintended consequences of genetic modifications, which can lead to unforeseen changes in organisms' behavior and characteristics. In recent years, scientists have explored the possibility of using GMOs to control mosquito populations, particularly those that transmit deadly diseases such as malaria and dengue fever. However, there are concerns that GMOs designed to target mosquitoes could inadvertently result in unintended outcomes, such as larger mosquito populations. Mosquitoes are notorious vectors of disease, responsible for transmitting pathogens that cause illnesses such as malaria, dengue fever, Zika virus, and West Nile virus. Traditional methods of mosquito control, such as insecticides and mosquito nets, have had limited success in reducing mosquito populations and controlling disease transmission. As a result, scientists have turned to genetic engineering as a potential solution to combat mosquito-borne diseases. One approach involves creating genetically modified mosquitoes that carry a lethal gene or a gene that prevents them from transmitting pathogens to humans. These genetically modified mosquitoes are released into the wild, where they mate with wild mosquitoes and pass on the modified genes to their offspring. Over time, the population of disease-carrying mosquitoes declines, reducing the risk of disease transmission to humans. While this approach holds promise for controlling mosquito-borne diseases, there are concerns about the unintended consequences of releasing genetically modified mosquitoes into the environment. One potential unintended consequence is the possibility of mosquitoes growing bigger as a result of genetic modifications. Genetic modifications intended to control mosquito populations could inadvertently affect their growth and development. For example, changes to genes involved in regulating growth hormone levels or metabolism could result in mosquitoes with altered body sizes. Larger mosquitoes may have longer lifespans, higher reproductive rates, and increased resistance to environmental stressors, potentially leading to larger mosquito populations in the long term. Additionally, genetic modifications aimed at enhancing the efficacy of mosquito control methods could inadvertently promote the survival and proliferation of larger mosquitoes. For example, mosquitoes that are genetically engineered to be resistant to insecticides may survive and reproduce more successfully than smaller, non-resistant mosquitoes, leading to the evolution of larger, pesticide-resistant mosquito populations. Furthermore, the release of genetically modified mosquitoes into the environment could disrupt ecosystems and food chains, leading to unforeseen ecological consequences. Larger mosquitoes may have different feeding behaviors and preferences, potentially altering their interactions with other organisms and affecting the dynamics of ecosystems. It is essential to thoroughly evaluate the potential risks and benefits of using GMOs to control mosquito populations before implementing large-scale release programs. Comprehensive risk assessments should consider the ecological, environmental, and public health implications of releasing genetically modified mosquitoes into the wild. At the heart of the ethical debate surrounding genetically modified animals are concerns about animal welfare, environmental impact, human health, and moral considerations. Critics argue that genetic modification raises significant ethical issues, including the potential for animal suffering, the disruption of natural ecosystems, and the unknown long-term consequences of altering genetic traits. One primary concern is the welfare of genetically modified animals and the potential for suffering and harm. Critics argue that genetic modification may cause unnecessary pain and distress to animals involved in experimentation or breeding programs. For example, genetically modified animals may experience unintended health consequences or developmental abnormalities as a result of genetic alterations, leading to reduced quality of life or increased susceptibility to disease. Furthermore, there are concerns about the environmental impact of genetically modified animals, particularly regarding their potential to disrupt natural ecosystems. Critics argue that the release of genetically modified animals into the wild could lead to unintended consequences, such as the spread of modified genes to wild populations or the disruption of ecological balance. For example, genetically modified fish engineered for faster growth or increased resistance to disease could escape from aquaculture facilities and interbreed with wild populations, potentially altering the genetic diversity and behavior of native species. Another ethical consideration is the potential risks to human health associated with consuming products derived from genetically modified animals. Critics raise concerns about the safety of genetically modified animal products, including meat, milk, and eggs, arguing that insufficient research has been conducted to assess the long-term health effects of consuming genetically modified organisms. Additionally, there are concerns about allergenicity, antibiotic resistance, and other potential health risks associated with genetically modified animal products. From a moral perspective, some critics argue that genetic modification represents a form of exploitation or commodification of animals, treating them as mere means to an end rather than respecting their intrinsic value and welfare. They raise questions about the ethical implications of manipulating the genetic makeup of animals for human purposes, such as enhancing productivity or altering physical characteristics for aesthetic or commercial reasons. However, proponents of genetic modification argue that it offers numerous potential benefits, including improved agricultural productivity, disease resistance, and medical advancements. They contend that genetically modified animals have the potential to address pressing challenges such as food insecurity, environmental degradation, and human health issues. For example, genetically modified animals engineered for enhanced disease resistance could reduce the need for antibiotics in livestock production, mitigating the spread of antibiotic-resistant bacteria and improving food safety. Likewise, genetically modified animals designed to produce valuable pharmaceutical proteins or organs for transplantation could revolutionize medical treatments and save lives. Proponents also emphasize the rigorous safety testing and regulatory oversight that governs the development and commercialization of genetically modified animals, ensuring that they meet strict safety standards and ethical guidelines. They argue that genetic modification has the potential to promote sustainability, animal welfare, and human health when used responsibly and ethically. So, what do you make of these giant mosquitoes? Be sure to leave your questions and answers in the comment section below and help us to grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.